Hello, my grade 11 chemistry class. Welcome to your video lesson on representing concentrations in solution. Hope you enjoy this lesson. We'll see you soon. Representing concentrations in solutions. So the last time we were together, we were talking about concentrations, we were talking about solutions, we talked about what the meaning of concentration is, and basically the meaning is we're talking about the ratio of solute to solvent within a solution. So here we have two pictures of solutions, and we've got solution B, we've got solution A, and you can see that solution A, it seems to have a few more of these yellow dots tucked in there among the, looks like it's an aqueous solution, so tucked in there amongst the water, whereas solution B here, its dots are much more spread out. So it seems that the solution B has a low concentration, solution A has a high concentration. And so what we want to do is we want to represent concentrations. We want to have a standardized way of representing concentrations. In fact, over the years there have been several different ways of representing concentration, and we're going to talk about a couple of these ways just now. Okay, so it can be expressed numerically a number of different ways. First method we're going to look at a measurable value. So it is called the mass to volume percent method. Okay, and so in order to calculate the concentration, what you're just going to do is you're going to take the mass of a given solute, which will be in grams, and we're going to divide that by the volume of the solution that solute is dissolved in. Okay, and then multiply 100%, and that gives us mass to volume percent of a solution. So here's an example right off the bat. A pharmacist adds 2 milliliters of distilled water to 4 grams of a powdered drug. So in this case, the 2 milliliters of distilled water, that's going to be our solvent. Our 4 grams of the drug will be the solute. The final volume of the solution is 3 milliliters. What is the concentration of the drug in grams per 100? Sorry, we're going to skip this question. Okay, just ignore that. What is the mass percent? What is the percent mass volume of the solution? Okay, so quite simply, percent mass to volume is we take our mass, so it's 4.00 grams, and we divide that by the volume. Now this is the only tricky part. We're dividing by the volume of the solution. So in this case, we're dividing by 3. We're not dividing by the 2 milliliters of water that we have. We're dividing by the volume of the solution that's formed when we dissolve that drug into water. So that's going to be 3.00 milliliters, and then we'll multiply by 100% to finish it off and turn it into a percentage. So this is going to be 133%. That would be a very high mass volume solution, mass volume concentration. Okay, moving on to our next example, also using mass volume percent. Here we're using an example where it gives you the mass volume percent, and we have to calculate something from that. So many people use a solution called trisodium phosphate, Na3PO4 is its chemical formula. It's commonly called TSP, to clean walls before putting up wallpaper, or for painting for that matter. The recommended concentration is 1.7% mass to volume. What mass of TSP is needed to make 2 liters of solution? Okay, so you're about to do some painting, you want to clean off the walls, you need 2 liters of the solution. You know you need to make the solution as concentrated as 1.7% mass to volume. So if we're going forward and solving this question, what we want to remember is that the percent mass to volume is equal to the mass in grams divided by the volume in milliliters, okay, times 100%. Okay, so let's plug in some values. Our mass, our percent mass to volume is 1.7%. Okay, and that's going to be equal to the mass in grams that we're trying to solve for, divided by our volume. The volume of the solution will be the 2 liters that is made up, so 2.0 liters, but we need our volume in milliliters, so I'm going to multiply by 1,000 milliliters per liter, okay, and then multiply by 100%. Okay, dividing by 100%, 1.7% divided by 100% times 2,000 milliliters is going to give us our mass, and our mass works out to be 34 grams. Okay, so that's another way of solving a question like that one. So we've seen how we can calculate concentration using the mass volume percent. The next way that we're going to look at is representing concentration using the mass to mass percent. Okay, and that's pretty simple. It's just taking the mass of the solute, okay, divided by the mass of the full solution, including the solute and the solvent, and then multiplying by 100%. So that's the mass to mass percent. So here's our first problem. Calcium chloride can be used instead of road salt to melt the ice on roads during winter. Determine how much calcium chloride had been used on a nearby road. To determine that, a student took a sample of slush to analyze. The sample had a mass of 23.45 grams. When the solution was evaporated, the residue had a mass of 4.58 grams. Assume there were no other solutes present. What was the mass to mass percent of the calcium chloride in the slush? And how many grams of the calcium chloride were present in exactly 100 grams of the solution? Okay, so let's start with the first question. What was the mass to mass percent of calcium chloride in the slush? So the mass to mass percent equation goes mass of solute divided by mass of solution. Okay, not mass of solvent, times 100%. Okay, so the mass of solute in this case, was the residue when all the solvent was evaporated away. So that's going to be our 4.58 grams. That's the residue. That's the calcium chloride residue. So 4.58 grams divided by mass of the solution. That's the full sample, the 23.45 grams. And we'll multiply that by 100%. And that should give us an answer of 19.53%. So now to tackle the other part of this question. Other part of the question was, how many grams of calcium chloride were present in 100 grams of solution? If we took a 100 gram sample of the solution we've been talking about, how many grams of calcium chloride would be in that? Okay, well, so let's write out our mass percent formula. Mass over mass percent is equal to mass of solute divided by mass of solution times 100%. Okay, so our mass percent, we know it. It's the 19.53%. Okay, mass of the solute, that's what we're trying to find in this question. Mass of the solution, we've been told the solution sample is 100 grams. Multiply through by 100%, and we can solve for our mass. This will tell us how much mass would be in a 100 gram sample of this solution. Okay, so the mass will be 19.53% over 100% times 100 grams. Okay, and that should work out to be 19.53 grams exactly. Okay, so now a third way that we can represent concentration is by using something called the volume percent. We've had mass to volume percent, we've had mass percent. Now we're dividing the volume by the volume. So volume of solute in milliliters divided by volume of solution in milliliters. Not the volume of the solvent, the volume of the whole solution in milliliters, and then multiply by 100%. So here's an example question. Very similar to the questions we've had so far. Rubbing alcohol is commonly used as an antiseptic for small cuts. It is sold as a 70% volume-to-volume solution of isopropyl alcohol in water. So what volume of isopropyl alcohol is used to make 500 milliliters of rubbing alcohol? That's the 70% solution of isopropyl alcohol. Okay, so volume-to-volume percent is equal to, in this case, 70%. Volume percent is 70%. And that's equal to the solute volume divided by solution volume. Multiply by 100%. Okay. So we take our 70% and we say that's equal to a certain volume divided by 500 milliliters of the solution of rubbing alcohol times 100%. Okay, and solving for volume, 70% over 100% multiplied by the 500 milliliters gives us 350 milliliters.